So we're going to go into chapter 17, and number 42 is our problem right now. And this, remember, this chapter is all about thermodynamics and delta H and delta S and delta G and figuring out if it's spontaneous. So this is a typical example. Calculate the free energy change for the reaction at 25 degrees Celsius. Remember, for free energy change, we're doing delta G, Gibbs free energy. And this reaction change is 25 degrees Celsius. And to remember, for spontaneity, we're looking at delta G and figuring out if delta G is going to let it happen. So remember, if delta G is less than 0, it's always spontaneous. And delta G is really the only way to figure out if it's spontaneous or not. So to figure out delta G, remember we have several things. They could be asking for products minus reactants or the natural log of K formula, but in this one we're asking for, you're given H of reaction, S of reaction, and the temperature. So we're going to use our other formula, delta G equals delta H minus T delta S. Remember I said the acronym in class, delta G is get higher test scores. So usually I just call it that formula. But, yeah, get higher test scores. Okay. So remember it's a minus sign in the middle though. Don't add it. Okay. So we have to figure out what our delta G is. In this problem, it was given to us what delta H and delta S were. If it wasn't given to us, you'd have to go in the table and figure it out yourself. Because remember, all of the reactions are always products minus reactant. So you could have figured it out. You could have figured out delta S and delta H from the table in the books by doing delta S of products minus reactants. Now remember, the signs and stuff are important and the units in this problem. So in this problem, we're just going to solve for delta G. We have delta H. If you notice off the bat, this is a joule, this is kilojoules. Typically, I would convert, it doesn't matter which one you convert, but I would just convert the joules to kilojoules because it'll be easier for the final answer and it'll be a smaller number. So I would convert this to the 0.364. We have it as, we'll just do it in a second here. So we already have delta H, kilojoules, minus delta T, 25 degrees Celsius. But remember, it's in Kelvin as a unit over here, so we need to be in Kelvin. So convert that to Kelvin is 298 when you add 273. Alright, so we have that going on, and then we have T, 298 Kelvin, times a negative 0.3646 joules per Kelvin. Alright, remember, kilojoules now. Kilojoules per Kelvin. Okay, so we have a minus sign in the middle and a minus sign here, so we're really adding. So our final delta G, once we solve for it, is going to simply be negative 1161. Oops, there's the negative 1161.1 kilojoules. Okay, so we were only worried we don't really care for the numeric number to figure out spontaneity. As long as it's negative, we are spontaneous. So since this is negative, we are spontaneous. Let's say spontaneous check. All right. Let me see. I just wrote spontaneous. All right. So we have the negative 1161 as our kilojoules. Now, you could have converted this kilojoules over here for delta H to joules. That would have also been correct, but I just typically convert it this way.